Okay, so earlier actually we saw how to characterize schedules based on recoverability, right? So how to recover from failures. Now, uh, uh, what we are going to do is characterize schedule based on serializability. So we said two important concepts with respect to transaction processing are concurrent access and recovery from failures. Okay. Concurrent access, that is concurrency control measures. That is one thing we said. And the other is recoverability. So we have characterized schedules based on recoverability. Next aspect we are going to look at is how to characterize schedules which are serializable. Serializable in the sense we can have multiple transactions executing concurrently, that is interleaving the operations at the same time. There are no errors. That is, all of them are interleaving their operations together, executing concurrently at the same time. The results are correct. Okay, so how can we characterize such schedules? That is what we are going to look at next. Okay, so now we are characterizing the type of schedules that are always considered to be correct when concurrent transactions are executed. Okay, so when transactions are executing concurrently, interleaving operations at the same time ensuring that the results are correct, then we can say that such schedules are said to be serializable schedules. Okay, now suppose two users submit transactions T1 and T2 to the system at the same time. Now, without interleaving, okay, without interleaving, there are two ways the transaction can be executed. That is, first, one second. First, T1 transaction T1 completely executes, followed by T2. That is one way of executing without interleaving. Or we can say T2 executes first, followed by T1. Now, such sort of schedules are called serial schedules. Okay, so this is how it works. So we know T1 is one transaction. It has these many operations. So first, all the operations in T1 are executed. After that, the operations in T2 are executed. This is one way of executing without interleaving. It is called a serial schedule. Okay. Now, this is another way. We can have T2 executing all the operations, followed by all the operations of T1. There is no interleaving. This is another serial schedule. Okay. Now, if interleaving of operations is allowed, there will be many possible orders in which system can execute the individual operations of the transaction. So, we said interleaving is actually a very basic concept. We had started with interleaving when discussing transactions, and we said that interleaving is required in order to have better CPU utilization. And but there are issues that can occur when we interleave operations or interleave operations. We said that we can have dirty read problems or lost update problems. So repeatable read might not be possible. Several issues we had discussed. So such sort of errors should not be occurring, but at the same time we want to improve the CPU utilization, and for that interleaving is necessary. Okay. Now, two possible schedules shown in the figure. The concept of serializability of schedules is used to identify which schedules are correct when transaction executions have interleaving of their operations in the schedule. So basically, we want interleaving to happen, but at the same time, we want correctness to be ensured. So such schedules are called serializable schedules. Okay. Say for example, okay, we can have this is the same transaction T1 and T2, but here we are mixing up or we are interleaving these operations. Okay. These are two ways or two schedules which are interleaved, schedule C and D. Earlier we said you had serial schedules. This is serializable. Two schedules which are serializable. Okay. Okay, so we talked about schedules A and B, that is T1 followed by T2 or T2 followed by T1. There is no interleaving, and such schedules are called serial schedules. And we have got C and D where we have interleaving of operations. They are called non-serial because each sequence interleaves of operations from the two transactions. Okay, now formally a schedule is serial if for every transaction that is participating in the schedule, all the operations of T are executed consecutively in the schedule. Okay, if it is executed one transaction after another, it is called a serial schedule. Otherwise, the schedule is said to be non-serial. Okay, and in a serial schedule, only one transaction is active at a time, so there is no concurrency. And the commit operation of the active transaction initiates the execution of the next transaction. Okay. So no interleaving occurs, no concurrency is there. Now the problem with serial schedules. A serial schedule ensures correctness, but the problem with serial schedules is that they limit concurrency by prohibiting interleaving of operations. So when a transaction goes into IO, other transactions have to wait. Multiprocessing is not supported. Hence, serial schedules are correct but infeasible. Okay, now if we can determine which other schedules are equivalent to serial schedules, we can allow these schedules to occur. So if it is possible for interleaving to happen and at the same time it results in the same, that is, if we can say that an interleaved schedule is equivalent to a serial schedule in terms of the results obtained, then we can allow these schedules to occur. Now you can. Okay, so if we look at, if we provide these initial values to the variables in the two transactions T1 and T2, and if we are trying to execute it in a serial fashion, that is either T1 followed by T2 or T2 followed by T1, then the expected database values at the end of the transaction will be this, that is x is equal to 89 and y is equal to 93. Now, if that is, we can you can actually go and try and work out these examples uh, for these schedules. That is either schedule A, schedule B, as well as C and D. You can use these values to work out what the value comes. Okay. So schedule A and B are serial schedules, and both of them will anyway give you values of x is equal to 89 and y is equal to 93 at the end of the transaction or end of the schedule A and B, and it is seen that D also will give you the correct values, but C does not. So we can say A and B are actually serial schedules, and D is actually equivalent to a serial schedule since it gives the same correct values even with interleaving. See, we can see that in D the operations are interleaved, but it still gives you the correct values. Okay, so we can say D is actually equivalent to a serial schedule. Okay, so that is what we want. We want several transactions executing concurrently. Operations should be interleaved. At the same time, we want the results to be correct. Okay, such sort of schedules are called serializable schedules. Okay, so the definition of a serializable schedule is a schedule S of n transactions is serializable if it is equivalent to some serial schedule of the same n transaction. If they are equivalent to each other. Equivalent is one aspect of equivalence is equivalent in the sense we can say the results the same set of output. Now, but more formally, how can we say that two schedules can be considered equivalent? Now, there are several ways to define schedule equivalence, and two definitions are one is conflict equivalence and one is view equivalence. Now, what is conflict equivalence? So conflict equivalence of two schedules. So two schedules are said to be conflict equivalent if the relative order of any two conflicting operations is the same in both the schedules. Okay, so two schedules are said to be conflict equivalent if the relative order of any two conflicting operations is the same in both the schedules. The earlier we had seen what conflicting operations are. So we said two operations are said to be conflicting if they belong to two different transactions and they access the same, say, variable x, and one of them is a write. That is what we said. In that case, we say that the two operations are said to be conflicting. Or, okay, it is written here. Two operations in a schedule are said to conflict if they belong to different transactions, access the same database item, and either both are right or one, at least one of them is a right. Okay, so that is when we say that two operations are said to be conflicting. And we say that two schedules are said to be conflict equivalent if the relative order of any two conflicting operations is the same in both schedules. Okay, now we come to what is known as serializable schedules. So using the notion of conflict equivalence, we define a schedule as to be serializable if it is conflict equivalent to a serial schedule as dash. Okay. So a serializable schedule is one in which is conflict equivalent to a serial schedule. Okay, so in such a case, we can reorder the non-conflicting operations until we form an equivalent serial schedule. Say, for example, so we can say this is a schedule A is actually a serial schedule, right? Because first transaction T1's all operations are executed, and when it commits, transaction T2 is being executed. So this is a serial schedule. Now, uh, uh, can we have or can we come up with a serializable conflict equivalent serializable schedule? So what we said is if non-conflicting operations can be reordered in such a schedule. That is what we said. Now, if we look at these set of operations, say read item y, y is equal to y plus n, write item y. It does not conflict with these set of operations, right? Although they belong to two different transactions, they do not access the same data item, so they are not in conflict. Okay, they are not conflicting operations, so it is possible that we can actually move this down later. So that is what is done in Schedule D. Schedule B, we are having the same transactions T1 and T2, but the non-conflicting operations are moved later so that we can have interleaved operations. And we saw that in Schedule D, it has the same results obtained as Schedule A. Right. But if you look at Schedule C, which we said, which did not give the correct result. So what we see is, say, there is a write item here, and there's a read item here. They are conflicting, right? Because they belong to two different transactions. They access the same data item, and one of them is a write. But we see that, look, in C, what is done is this read item is actually moved to a point above the write item where, so you see the relative order of the two. So what is the definition for a serializable schedule? It is conflict equivalent to some serial schedule. And what do you mean by conflict equivalence? The relative order of conflicting operations are same in both schedules. So here we have two conflicting operations. This is one and this is one. And in this schedule, it is first a write comes, then a read comes. But here a read comes and then the write comes. So the order is different. So they are not conflict equivalent. Okay, so that is a concept.